All right, let's do this shit. Hey, Teach, how's it going? Just came back from the final. Uh, I might have failed that shit. I'm not gonna hold you, or not. I don't know. I'm kind of kidding. But let's get into this. So let's start with what our final scene looks like. Now, I'm gonna warn you. When you look at this the first time, you're gonna think this is some bullshit, and it looks like bullshit. But trust me, there's a method to this madness. So this is inspired by this image, which is from this really cool manga called Chainsaw Man. I don't know if you're into anime, but I highly recommend it. But I'm not going to shill too much about it, but it's dope. So I was inspired of this because we have all these doors, this beautiful field. So it's like, okay, there's flowers, there's some shoes and people. I can try that. Um, so throughout this project, dealing with a lot of the model intricacies was really annoying, but we managed to at least get a little bit working. So what I'm really proud of here is this cool wind shader that I did. And to render all these fucking doors and stuff, what I did was I actually implemented the hardware instancing stuff. So the frame rate stays somewhat okay. It's a little low here, mainly because I'm recording this with OBS, which takes out a lot of resources. But yeah, so I tried to show off everything. There's a big direct light coming through onto the textured scene, and you can see lights on the flowers. I tried to vary the colors a bit with by sending different materials, but didn't come out exactly how I wanted. And I was trying to find a way to include the spear, so I made a fake rock by putting a spear on the ground. You can also notice that so the back of those flowers, usually those get culled. So I actually did set up a state to uniquely not cull it, but only for the flowers. And up here are the doors. So obviously I had to use instancing for this because this door model is actually pretty fucking bad. Like the handle it has a lot of polys. So, and I had a hard time getting another lower poly door to import correctly without me doing editing myself. So, is what it is. I had it set up so it would like have random light materials per each door. So that's kind of cool. And for an example of a moving light, I was trying to think, since it's daytime, I couldn't really think of a natural thing to do. So what I did is I had this cool effect where I basically have 2 point lights that follow the X and Z position of the camera while staying like above so it can hit the doors. So it looks like an eye is following you, which I think is really fucking sick. I was really proud of how this came out. And finally, we have this fog effect, and I'm only using that on the doors. And basically, it's just fading into blue the further the doors get away from the eye, which kind of has it, not entirely, but it kind of fades into the background of the skybox, and I think that looks really cool. Um, so yeah, yeah. So also, I have only like 2 gigs left in my drive, and I guess during the process of this sending a shit ton of stuff to GPU, that shit fills up. So don't worry about that. But yeah, let's just go through the code. So So the way this is designed is, a lot of this is kind of set up how you set it up before. But let's just go through our init demo sequence right here. So what we do is we load the shaders, right? So basically, we just add all the shaders that we're using and just set them up so they can be used later. Pretty simple. And then after that, we load our assets. And by assets, I mean our different textures, our terrain model, since that's based on a TGA file. We also create our skybox here. This probably should move to create graphics objects, but whatever. And then we also add our models. So we don't have any fancy asset library, so what I did is I have a vector of models that I can just reference whenever I want. Also for model loading, in case the model was fucked up, I added a way to edit the transform of the model as it comes in, and so it doesn't fuck with the lighting. I think I did something extra so I can take care of that. So in private load data from file, I give a transform, and then it takes that transform, right, and then it multiplies everything by that transform while doing the stride and setting the vertices and stuff. So it actually like modifies it before it goes through any like rendering or anything. So pretty proud of that. All right, so after we're done loading assets, then we're ready to create our graphics objects. So real quick, let's look at our header file for our DX app and see here. So we have a color object. This is for the skybox that we have, and it's unlit. We have our rock, which is just I just wanted a gray spear to represent a rock, kind of arbitrary. So yeah, it's just a color light shader. Um, we have our actually our texture shader. Whoops, our texture shaders for our skybox. I think this is unused right here. And then we should have named these, but we have three texture lights for our terrain and something else I think. But let's go through. And for our instance stuff, we have a concept called a multi-model grid and multi-model terrain. More on that in a second. So back over here. So this is where we create our graphics objects. We're not using this one right here, but that's just still there. We use a graphics object texture for the skybox. Let's see, for this one, P model 0123, that is unused at the moment. Let's see, 22012. That is used. Oh, okay. Now I remember. So yes, we do use graphics. We do use these graphic object texture lights for our instancing, and I will get more into how that works exactly shortly. Um, but yeah, so basically we create the graphics objects, and then let's see, in init demo, I think that's it. Oh, and then for any static lights, we make sure to do that before the update scene. So for each texture individually, we set up their lights, and I just commented out to make it simple. So I actually have a separate shader class to act on our instanced objects. Um, and the reason I do this is, well, for one, I have a different shader entirely for instancing. But you know, I keep talking about instancing. Let's just dive into that a little more, right? So, there we go. Okay. So basically, this is kind of a one. It's pretty close to the normal shader texture file, and just for context, so our shader file, what it does is normally it sets up your input layout, it compiles your shader asset for you, sets up your buffer restrictions, creates your buffers for the camera matrices, light params, or the material, however you set it up, however you want to communicate with your shader. Then it handles deletion. It can send It can send anything it needs to the GPU every frame or once before you even start rendering if you want. Yeah, so shader class just makes all of this really easy without me having to manually write commands to DirectX. Just to explain that. Now, where our instance difference, our instancing class differs is that it, well, to be honest, it doesn't really differ that much at all, except for when it renders. So how instancing works is instead of just setting like for instance here, we per vertex will send like a position, text, chord, normal, and color. When we're using instancing, we also have a concept of an instance buffer. And an instance buffer contains data that varies per instance. For instance, world and world inverse, and additionally, material. That's how I do the randomized material colors for those doors, for instance. So this gets passed through on the on an additional buffer. That's why we have the one here, because it's indexing over there. Um, and then ultimately, when we call in our graphics objects, that's using an instance shader, graphics object texture light. Well, okay, let me explain the graphic object real quick. Okay, so these handle the relationship between models and shaders, as well as textures and their world matrices. So basically, it's just more abstraction, so I don't have to write a bunch of DX commands, basically, to have a proper graphics API. So normally you can just set like a material on it so that it can send that material along with the world information to the GPU. So when I call render, it just does all this shit for you. It calls its associated shaders, set the context. it sets its associated shader's texture with the texture you set to the object, and then it sends the world and material, and you can just call this every frame if you want. Now, I probably should have made it a separate class, but I also gave it the additional ability to render instanced meshes. Models. So what it does now is we have a function that we added to our model class that does an instance render. And basically, there's this built-in thing called draw index instanced. That basically it's the same thing you call to your draw index, where you have your index count, start index location, base vertex location, but you now also have an additional variable notifying how many instances you want to draw, and then it will use that. It'll use that to grab the associated information in the instance buffer. So we have this count thing that you set to set how many instances do you want to draw for that frame. So this is a lot better than calling render, making a bunch of different objects to call on the same model, because that back and forth between the CPU and GPU is like super time costly. So this basically lets you just batch it all in one. And yeah, so I basically built the graphics objects for the texture light specifically to be able to take in instanced and regular single draws. All right. So basically from there, so yeah, so we have our render instanced, and we do that to call that, yeah. So now I want to get into, I guess I want to explain kind of the internals of the actual shader here. So we have lighting. So in our so we have a separate shader for our instance variables, but this basically includes everything I've learned about shaders all in one file. Obviously, in a real project, I would probably make actual library files because I repeated all this lighting calculations a bunch of times, which feels like a huge waste. But for the sake of learning, this was the simplest way to do it. So yeah, so we have our different lighting calculations. We have the Phong model, which takes in the material of your object, your light intensity, L vectors, normals, direct to the eye, calculates all that, and then we have the constant buffers defined here. So when we pass in the CAN data, these are all set up to separate registers. We pass in the view and projection matrix in one buffer. We pass in all the light parameters that vary, that can vary per shader, in one C buffer. And then we also now have the concept of instance data. And right now, normally in our old texture light shader that we use for non-instance thing, our instance data buffer would contain the individual world inverse, and material. But since we're dealing with different instances, we have to pass that within our input assembly step. So now this just contains the material. And additionally, we also have, so for that wind effect that I showed you, I also set up a way to influence that, like wind direction time, force, speed, frequency, and the ability, and whether it's on or not. So this is kind of built off that fog example that we did. And so I'll go over the wind stuff actually real quick because it's pretty cool. I stole it online. I followed like a Unity tutorial which did it through nodes, and then I kind of brute force extrapolated it into code. So basically, it takes in all those wind params and does a bunch of calculations that basically basically offset the different vertices. And what's cool about this is for like super tall objects like trees and stuff, it has this more realistic effect where the higher that object is, higher the position on that model is, the more of the effect of the wind it will feel. And there's some randomization here with this lerp that, well, not randomization, but like it kind of like naturally like goes faster and slower depending on how you like tweak it, which is pretty neat. And then in our pixel shader, this is happening in our vertex shader. In our pixel shader, this is where we do the fog, which pretty simple stuff. For my example, I just made it fade to blue, like I said earlier. Okay, are we doing on time? Yeah. So let's see. Did I explain everything here? Let's see. So I guess I'll go back through the flow here. So we initialize static lights for each shader. And then let's see, after that, after that we set the camera perspective and position. I just set it to what you see in the demo so it looks nice. And then we're ready to run. So we basically every frame we update our scene, which updates our camera positions. And I'm not doing any like time based world position changes. I am doing time based stuff for wind though, and we'll see. So let's just go through our draw scene run, right? So basically, I set it up so we update the shader params, send the new parameters, whatever it needs, camera, light, wind, whatever it needs. So we just do that in just little chunks here. This is where I get do that cool eye effect by having two separate point lights that both track me. And so I have like a white one that's really big and a black one that's a little smaller. So that's for the pupil. That's pretty cool. And then down here, this is where we render stuff. So we render the rock, yeah. And then over here, we send the fog parameters only for the door grid. And this is using our instancing shader class. We render the door grid and then we turn it off. That way the fog doesn't show up on the flowers, which is under the same shader. And let's see. So let me go through our door grid real quick. So how the door grid works is basically now that we have the ability to instance stuff, now we can, put our world matrices for each instance in a bunch of varieties. So I did a simple grid or like a plane that basically it just goes like in a x by x and z, and you can set the spacing of your grid when you create it. You can set it on the x and z level. Right now it's the same, and basically it'll just draw. It will set the world at like those spacings within that grid, and then based on the world you send it, it uses that as its center and then fans out. That way, I don't have to like position it by the corner, which I was dealing with before. And then we also use a standard SRAM function to randomize the type of color material that it sends to each instance, which makes it really cool and like dynamic and stuff. Every time you start it, it's a little different. Yeah, it's pretty simple. Like high level, this looks really simple, even though a lot of the instance stuff is like it was a lot to wrap my head around. So going back out here, so we're done with that. Now we render the foliage. So here, this is when we send the wind parameters. We also turn backface culling on because our flower model is, by default, it can't see the backface, and I kind of wanted the camera lower so I could see it. So I just turn it on, turn it off. I didn't seem to notice much of it. Performance impact, considering I'm only doing on the flowers, and as soon as I'm done with the flowers, I turn it off. But so let's go to our foliage. So our foliage is part of something called a multi-model terrain class that I built. And basically how its set world works is what it does is a multi-model terrain. So it takes in a terrain model, like our previous terrain model, and then uses the normals of that terrain model to determine the positions of the flowers. I also wanted to do some normal rotation stuff to make it look more natural, but I kind of ran out of time there. So, it looks solid. It looks clean. I think it looks clean, the way it is. So yeah, like I said, so basically, yeah. So it gets the position of each vertex and then just sets that world position to that vertex, and it's like it's popping out of the tree, and there you go. Yeah. So, I also tried to do the color variation, but since it's already textured and stuff, if I figured out the way to do varying textures, this probably the flower stuff would have been more interesting. All right. So there's some weird comments in outcode here because what I'm doing right now is I copied your example from the visualizer to actually only generate a certain number of these flowers based on your camera position on startup. Not it doesn't do it dynamically or anything because that would also be a performance impact. So the result, it looks okay, and then it just like fades out, because that's really all you need to see. What I originally wanted to do was implement frustum culling, but I did not have the time to wrap my head around the quad tree stuff. So in this code, I do have a quad tree node class, but I think there's probably something really small with my bounding logic that's not working. But yeah, this shit does not work. So I commented it out and just went for the camera route just to get it out the door. But ideally, it would be cool if I got this to work, because then you could just see all the flowers over here, but everything to the side and behind you, they'd be gone. So hopefully, I'd be able to keep this 60 to 70 FPS on my machine, and while still being able to show as many flowers as I want, as long as you're looking that way. Unfortunate, but it is what it is. Um, but yeah, so really not much going on here except mapping the flowers to the vertex positions. All right, so back over here. So we're done rendering the flowers. We turn the wind off. We turn back the regular culling back render state. I have two separate ones here. Okay. And then we render the terrain. Pretty simple, and then we're done. And after that, we delete all of our models. I obviously nothing replaces like a proper asset loader library, but for these textures, probably could have just had a vector here. That would have been helpful, so I don't have to keep adding it manually. And then we just release and delete everything, and yeah, we're done. Pretty simple. Trying to think if there's anything else I didn't go over. I didn't do a mirror effect. I just thought, fog would be solid enough. I'm pretty happy with this. I I should check that, double check that Rubik. But yeah, um, yeah, this was fun. I really do want to figure out frustrum cloning in my own free time for sure. But yeah, that's it. Bye bye.